In this video, I'll be helping you with the ALEKS problem type called finding the inverse of a 3x3 matrix. If this is the first time you are attempting to find the inverse of a matrix, I would first watch the video on finding the inverse of a 2x2 matrix because the process is going to be the same. This is just going to be more. And I'll start by noting that we're finding A inverse. If it does exist, then A is non-singular, and we will give that inverse function as our answer. If at some point in the process things sort of fall apart and I'm not able to get the identity matrix, then we would say that A is singular, meaning that it doesn't have an inverse. And again, when we multiply a matrix with its inverse, I'll get the identity matrix, regardless of which order I multiply in. And the identity matrix for a 3x3 or any size matrix is always square, with ones on the diagonal and the rest of the values being zeros. And our method for finding A inverse is to start by listing A, and then we use this separator. On the right hand side, I list the identity matrix, and then from here I can multiply rows by constants and I can add and subtract rows. And my goal is going to be to turn this left hand side into the identity matrix, and then I will have A inverse on the right hand side. So to start, I'm going to choose that upper left hand value, which is a 6, and my goal is to turn this left hand side into the identity matrix, so I want that to be a 1. And as I said, I can do row multiplication here. I can multiply this row, this first row, by a value. So I will multiply it by 1/6, because that will turn that first element into a 1. So I'm going to rewrite, and since I'm not going to be using the second or third row for this first step, I'm just going to rewrite it, and then I'm going to distribute. I'm multiplying everything in row 1 by 1/6, so 6 times 1/6 is 1. And again, that was my goal, to get a 1 in that upper left hand corner as I'm manipulating this left hand side to turn it into the identity matrix, and then continue my distribution. 2 times 1/6 is 2/6 or 1/3. For now, I like to leave this as not simplified. So 2/6, and then the next element is also a 2, so 2 times 1/6 is another 2/6. On the other side here, where we had the original identity matrix, 1/6 times 1 is 1/6, and then I've got 1/6 times 0 is 0, and then the last one, 1/6 times 0 is 0. So in this first step, all I have done is row multiplication, but now I have this 1 in the upper left hand corner. Next, I'm going to move to that second row, and my goal is to get a 0 in that next value. And since that's a -1, all I need to do is add row 1 to row 2, and that would give me a 0. For now, I'm going to go ahead and write down row 1. And since I'm just adding row 1 and row 2 with no multiplication, to get my new row 2, 1 plus a -1 is 0. And then continuing the addition, 2/6 plus 0 is 2/6. 2/6 minus 1, I can say that that's minus a 6/6. So that gives us a -4/6 in that space. And then continuing my addition on the right hand side, 1/6 plus 0 is 1/6, 0 plus 1 is 1, and 0 plus 0, 0. Again, I'm just adding row 1 and row 2. So far so good. I have given myself a 0 in that second space, but I also want a 0 in this first column for the third spot as well. So I can go back to my row 1 now that I have a 1 in it, and here I can see that if I multiply by a -3, that would give me a -3 in the first place. And then if I add to row 3, that would cancel, giving a 0. So that is my goal. -3 times 1 is -3, plus 3 is 0. -3 times 2/6 is -6/6, or -1, plus the 6. So -1 plus 6 is 5. Again, -3 times 2/6 is again -6/6. Adding row 3 here, which is a -2, I've got -1 minus 2, negative 3. Negative 3 times 1 6 is negative 3 6. Again, I'm going to leave this unsimplified when I add it to 0 and just say that is negative 3 6. Negative 3 times 0 is 0, plus 0 is a 0. Negative 3 times 0 plus 1 is 1. So again, I've taken another step here, and I now have this first row entirely as I wanted it to be. 1 in the top and the other two values are 0. So I'm going to keep going, and for the next step, I want this value to be a 1. So I can do row multiplication, and here if I multiplied this entire row by 3, then that would give me a 1 in that middle spot. And for this step, I'm only going to be working with that middle row. So row 1 and row 2 have been just brought down, and now I can multiply by 3 across row 2. 3 times 0 is 0. 3 times 2 6 is 6 6, or 1. 3 times a negative 4 6 is a negative 12 6, or negative 2. 3 times 1 6 is 3 6. 3 times 1 is 3, and 3 times 0 is 0. So again, I'm one step closer. I have the 1s and 0s in column 1 that I want, and I now have that 1 in the middle column. And I can use the fact that I have that 1 to turn these values into zeros. And that's what I'm going to do in the next step. I'm going to leave this middle row as it is, but since I have that 1 in the middle spot, if I'm trying to make that top 2 6 into a 0, I can say that I'm multiplying the middle row by a negative 2 6 and adding that to the top row. So distributing negative 2 6 times 0 would be 0 plus 1 is 1. Negative 2 6 times 1 is negative 2 6. I add the 2 6 on the top. That gives me a 0. Then negative 2 6 times 2 is a 4 6. And then I add row 1, which is 2 6. That gives me 6 6, or 1. Continuing, negative 2 6 times 3 6 is negative 6 over 36, which, to keep my denominators here 6, I will go ahead and reduce that to a negative 1 6. And then I'm adding in the top a 1 6, so that becomes 0. My next multiplication is negative 2 6 times 3, which is negative 6 6, plus that 0 in the top. So negative 1 plus 0, negative 1. Negative 2 6 times 0 is 0, plus the 0 in the top is a 0. So I use that 1 to turn the top row into a 0. And now I need to do the same thing for the bottom row. So for the bottom row, I have a 5 in that spot. I need to multiply the middle row by a negative 5 and then add that to the third row. So negative 5 times 0 is 0, plus 0, still 0. Negative 5 times 1 is negative 5, plus 5 is 0. And again, that's my motivation here, is I wanted to get a 0 in that spot. Continuing the row multiplication, negative 5 times negative 2 is 10, minus the 3 would be 7. Negative 5 times 3 6 is a negative 15 6, but I need to add the negative 3 6. That gives me a negative 18 6, which is negative 3. Negative 5 times 3 is negative 15, and I need to add the 0, so negative 15. And then negative 5 times 0 is 0, plus the 1 is 1. So far with my manipulations, I have the 1 and 0s that I wanted in the first column. In the second column, I have the 0s and 1 in the middle. Next, I want to turn this cell into a 1, and I can do that by multiplying this bottom row by 1/7. And in this step, again, I'm only going to do this multiplication, so I'll go ahead and rewrite rows 1 and 2. Multiplying each element in row 3 by 1/7 gives us 1/7 times 0 is 0. 1/7 times 0 again is 0. 1/7 times 7 is 1. And again, that was my goal, to get a 1 in that spot. Continuing the multiplication, 1/7 times negative 3 is a negative 3/7. 1/7 times negative 15 is a negative 15/7. And 1/7 times 1 is 1/7. And then the last thing that I need to do to turn this left-hand side into the identity matrix is I need to zero out these two values. And I'll do that by using the third row that I now have a 1 in that position for. So our bottom row looks good as it is. Looking at row 2, I can zero out the negative 2 if I multiply the third row by 2 and then add it to row 2. Multiplying by 2, I would have 2 times 0 is 0, plus 0, still 0. 2 times 0 is 0, plus 1 is 1. 2 times 1 is 2, plus negative 2 is 0. 2 times negative 3/7 is negative 6/7. And I need to add the 3/6. So I'm going to go ahead and reduce that and get a common denominator. 3/6 is 1/2. A common denominator would be 14. So on the left-hand side, that would be a negative 12/14, plus on the right-hand side, 7/14. So when I add these, I get a negative 5. For the next spot, I have 2 times negative 15/7 would be negative 30/7, and I need to add 3. So I'll go ahead and get a common denominator. 3 would be 21/7. So adding gives me a negative 9/7. And then 2 times 1/7 is 2/7 plus 0, 2/7. So we've completed row 2. In my final step, I'm going to use row 3 again to zero out the last element in row 1. So in this case, I can just multiply the bottom by a negative 1 and then add it to that top row. Negative 1 times 0 is 0, plus 1 is 1. Negative 1 times 0 is 0, plus 0 is 0. Negative 1 times 1 is negative 1, plus 1 is 0. Negative 1 times a negative 3/7 is 3/7, plus 0 is just 3/7. Negative 1 times a negative 15/7 is a positive 15/7, but I need to add a negative 1, so I will add a negative 7/7 to get a common denominator. This would give me 8/7, and then negative 1 times 1/7 is negative 1/7 plus 0, negative 1/7. So with all of these steps and being extremely careful along the way, we have turned this left-hand matrix into the identity matrix, and the right-hand matrix is now our A inverse. So A was not singular. It does have an inverse, and we were able to find it. If it would have been singular, then at some point we would have inadvertently zeroed out these 1s that we were trying to get on the diagonal. That would have made the process fall apart. But in this case, we were successful. There is an inverse matrix, and we found it.